Alright everybody, let's try this one-to-one functions video again, since for some reason it didn't record the audio last time, which is kind of frustrating. So one-to-one functions, remember a function is a relationship if, a relationship is a function if for every input there's exactly one output. Right, and so we've looked at things that were functions back in Math 1. You guys looked at the function machine and all that fun stuff. But what we're going to look at today are one-to-one functions. Now, a one-to-one function, a lot of you, when we first start talking about functions, you want functions to be one-to-one. It's kind of something that just happens. It's, as we're talking about the definition, we ask, well, why couldn't it be this way too? And it ends up just being a little bit more than a regular function. So a regular function is a relationship where you have one output for every input, and then for a one-to-one function, you start off with a function. So it's a function first and foremost, which means it has this relationship of one output for every input. And now in order for it to be one-to-one, a function is one-to-one if for every output this time, there is exactly one input. So what we're looking at here with these is we're looking at the idea that for every output, there's only one input. Before it was for every input, there's one output. But now it's going the other direction as well. So if we remember when we're looking at graphs, if we want to check to see if something is a function, we have what's called that vertical line test. And with the vertical line test, that's where we take our pencil or another type of straight line, and we go across and we see if our function only touches it once. If it does, then it's the function. The next thing is for a one-to-one function, to test to see if it's one-to-one. If it passes that vertical line test, then we actually use a horizontal test. Horizontal line test, to see if it'll work the other way as well. So I'm going to go ahead and let's look at some graphs and see if we can decide, are they a function and are they one-to-one? Remember that in order to be a function, it actually has to be one-to-one as well. So I'm going to zoom in here so we can look at these one at a time. So this first one, I'm going to take my ruler, because it's going to be easier to see, and I'm going to try that vertical line test first. Remember, the vertical line test is as I'm going along this relationship, this graph, it's only touching it in one point. That means for this represents an x value, and that means it's only got one output. So for every input, there's only one output. That means that this one is a function. Now to check to see if it's one-to-one, I'm going to do that horizontal line test. I'm going to go like this. So I'm checking to see if for every output, or for every y value, it only has one point that it's touching. That means one input that gives me that. And in this case, linear functions are all one-to-one as well. If I look at this next one, this is a quadratic, a parabola. As I go from left to right with my vertical line test, I can see that yes, this one is a function. Right? But as I look at my horizontal line test, if I'm looking right here, should I go right here because these are nice outputs. When I have an output of y is equal to 5, I have two different possibilities for inputs. So this is not one-to-one. Okay? Let's look at the next one. As I go across this here, it is a function once again. This one is a function because it is going straight across. It's only touching my curve in one point as I go from left to right. But then as soon as I switch to that horizontal line test and I start moving that horizontal line up and down, you'll notice in this case, I have three different inputs that give me this possible output. It's touching it in more than one place. Even right here, it's already touching it in two. So if I have more than one input for an output, then this is not one-to-one. if we look at this one, I've got 2 check marks from my previous video, but as I go from left to right, you'll notice that this one is a function, so there's my first check mark. And then my second one, this is a cubic function. We're going to look at these in more detail here in the upcoming weeks, but as I go up and down, you'll notice it's only touching it once. It looks like right here it might touch it more than once, but this right here is just a change in direction. It's going up, and then it goes up some more. So it slows down and then speeds back up. So it really only touches it once there, even though it looks like it touches it more. So this one is a function, and it is one-to-one. The next ones are examples of things that are not even functions, right? If I'm looking at this one and I'm going from left to right with my vertical line, I have 2 outputs for 1 input. That means it's not a function. If I look at this one, it's also not a function. So because it's not a function, I don't even have to check to see if it's one-to-one. Okay? Zoom back out here. So now that I've looked at graphs, we're now going to look at what if we have a set of points. Remember, a relationship could also be given to us in the form of a set of points. And so if I've got 0, 1, I've got 3, 2, 2, 4, 3, 1, and then 5, 6. So looking at this, this is also a relationship. What each one of these points tells me is that if I plug in an x, I'm going to get out my y. So if I plug in a 0, I get a 1 out. If I plug in a 3, I get a 2. If I plug in a 2, I get a 4. If I plug in a 3, I get a 1, and so on. Now, if I'm looking to see if it's a function with these, checking to see if it's a function, remember that's always going to be our first one, we look for repeated x values. The idea is that we want to make sure that if I have an x value that's repeated, an input that's repeated more than once, that it goes to the same output. In this case, if I plug in a 3, I don't know to tell you whether it goes to 2 or 1. I have 2 different outputs for 1 input. So this one is not a function. Okay. Let's look at another one. Let's say that g of x is this set of points. I've got 2, 2, 3, 4, 4, 2, and then 6, 0. So if I'm looking at this one, my first check is it a function? And if I look, I've got 2, 3, 4, 6. Yes, it's a function because there are no repeated x values. Is it one-to-one is my next guess. Or my next question, actually. And for one-to-one, we're not going to be looking for repeated x values. We're going to be looking for repeated y values. So if I'm looking here, I'm looking for repeated y values. I have this one right here and this one right here that are causing problems. With these two, I have 2 different outputs that come, or to the same, I have the same output with 2 different inputs. If I was to graph these real quick, this one right here would be at the point 2, 2. This one would be at the point 4, 2. Notice that it would not pass that horizontal line test, right? A horizontal line would go through both of those. So this one has repeated y values, so it is not a one-to-one function. It's a function, just not one-to-one. Let's look at one more just to make sure that we understand how to check these. So if I've got -1, 2, 0, 3, 1, 4, 2, 5, and then 3, 6. So looking at these ones, my first check is it a function? And so I've got -1, 0, 1, 2, 3. I have no repeated x values, so I know that it's a function to start off with. And then is it one-to-one? So I've got 2, 3, 4, 5, 6. It is one-to-one because I also have no repeated y values. Okay? So hopefully this one recorded with audio. And hopefully my kids are not too loud in the background. And I will talk to you guys later.